Okay, let's take notes in section 9.4, which is on multiplying and dividing rational expressions. So this section I like this section because it'll help us review a lot of what we did this semester. So it'll help us review exponent rules, factoring, and multiplying polynomials, which you'll all need to know for your final. So first, let's define a rational function. So a rational function is a function that is defined by a polynomial divided by another polynomial. And in parentheses, I'm going to put fraction because these are basically functions that are in the form of a fraction. In the simplified form of a rational function is when the numerator and denominator have no common factors. So in order to get a rational function, factors. In order to get a rational function in simplified form, here's what we need to do. So to simplify, we need to factor the, I'm going to say the top and bottom. So the numerator and denominator. So the top and bottom of your rational function. And then we're going to cancel out. So you're going to cross out any common factors. So you cross them out and then rewrite your function without them, without those common factors, and then that's it. So part one, we're just simplifying here. So simplify each expression below to be in lowest terms. So let's start with number one. So let's factor the top and bottom. So with this, we're going to think about a GCF. So this is an example using just GCF. Because there's no other type of factoring we can do here. So let's factor a GCF out of the numerator. So in the numerator, we have 2x minus 10, which they have a common factor of 2. And then we'd be left with x minus 5. So again, think of GCF as a reverse distribution. So what goes into both 2x and 10? Well, 2 goes into both of those evenly. So if I take a 2 out, I would just be left with 1x minus 5. Now in the denominator, we only have a 4x. So I'm going to just write that because that can't actually be factored because it's just one term. But we want to try to cancel something out with the numerator. Our options for canceling are 2 and x minus 5. Obviously, we can't get an x minus 5 out of a 4x, but what about a 2? So if we factor a 2 out of the denominator, we would have 2. You can factor a 2 out of 4, so you'd have 2 times 2x. And that's exactly what we want because now we have a common factor. We have a common factor in the numerator and denominator, which means we can cancel them out like that. And now what we're left with is just x minus 5 over 2x. So that's the idea here. You want to, let's make that 2 actually look like a 2. The idea here is you want to take out a common factor in the numerator and denominator, and then cancel them out. And whatever you're left with is your simplified radical expression. Hang on a second. Why does it say radical? That's not right. Rational. Sorry about that. All right, so this one we're going to do GCF again for number 2. Because there's no other way to factor these. So start by taking out what we can in the numerator. So in the numerator, we have x squared plus 6x. So we can take an x out of that because they both have x's in common. We've got x squared, we've got x to the first. So we can take an x out. And then what you'll be left with when you take an x out of x squared, you're left with x. When you take an x out of 6x, you're left with 6 over. Now in the denominator, they don't both have an x in common, so we can't factor out an x, but our coefficients are 5 and 30. 5 go into both of those, so let's take out a 5 and see what happens. So if we take out a 5, we're left with x. And then if you take a 5 out of 30, you're left with 6. So this time, we did end up with a common factor, x plus 6 and x plus 6, so we can cancel those out. And what we're left with here is x over 5. So a good starting place, just a little note, I'm going to say start with GCF if you can. You can't always, but if you can, start with GCF. It's a good place to start. See where that gets you. All right, next example. So in this one, this is an example where GCF will not get you anywhere, because if we're looking at the numerator, we have x squared minus 4x minus 12. Those three terms do not have something all in common. And the denominator is x squared minus 4. So we don't have anything in common there. So we're going to do two types of factoring here. So the first type of factoring is, let's say, trinomial factoring. So I usually refer to this as regular factoring. There's no such thing as actual regular factoring, but that's what I call it. It's a quadratic when a equals 1. And we're also going to do difference of two squares. So two things to review here, trinomial factoring and difference of two squares. So in the numerator, that's a trinomial, a quadratic trinomial, because we have three terms, and our highest degree is an x squared. So what we're going to do is, let's factor. So we want to ask ourselves, what adds to negative 4 that multiplies to negative 12? So adds to negative 4 that multiplies to negative 12. That would be x minus 6, x plus 2. Just as a side note, just so you know where that came from, negative 6 plus 2 equals negative 4, and then negative 6 times 2 equals negative 12. So that's our factored numerator. In the denominator, we have a difference of two squares. So the way we factor that is x plus 2, x minus 2. So just so you know where that came from, we have x squared minus 4. A equals the square root of x squared, which is x. B equals the square root of 4, which is 2. So the way we factor that is a plus b, a minus b. So it's x plus 2, x minus 2. So that's how we factored the denominator. All right, so now that we've done this, we do have a common factor here. Let's do yellow. So we have x plus 2, and we have x plus 2. Those are exactly the same, which means we can cancel them out. And then what we're left with is x minus 6 over x minus 2. And that is our simplified version. Okay, so next one. So this one is actually going to deal with GCF again. So we're going to start with GCF. Now in the numerator, it's just one term, so we don't actually have a GCF. So when you just have one term, just leave it as is. So let's make a note of that. So if you have one term, if you only have one term, leave as is for now. And then we'll see what we can do with it after we factor the bottom. So you can write that if you want. So leave it as it is for now, and then we'll see what we can do once we factor the bottom. All right, so 3x cubed over. All right, so we have 12x squared plus 9x. So we've got a 12 and a 9. So we can factor a 3 out of that. But we've also got an x squared and an x to the first, which means we can take out an x to the first. All right, and then we're left with, well, we took a 3 out of this 12, so we're left with 4. We also took an x out of this x squared, so we're left with 4x in our first term, plus we took a 3 out of the 9, so we're left with 3, and we took an x out of here, so that's what we're left with. And this actually works out nicely because now we have 3x, and we have 3x cubed at the top. So something interesting happens here. So clearly, this is clear to me. We have a 3, we have a 3. That's a common factor, right? So those can cancel each other out. But now we have an x cubed over x. So we can definitely cancel out one of those x's, but here's why. So we've already canceled out 3. So x cubed is the same thing as x times x squared, right? So then we have x times 4x plus 3. So now once you write it like this, it's very clear that you can cancel out one of these x's like this. Another way you could think about this is using exponent rules. You have x cubed over x to the first. 3 minus 1 is x squared. But just to stay consistent with what we're doing in this section, so canceling factors, you could also just factor out the x like this, cancel on out. And then what you're left over with is x squared over 4x plus 3. All right, next one. So now we have two trinomials. So for this one, the type of factoring we're reviewing is just factoring trinomials. In this section, we're not going to deal with any trinomials. Let me spell that right first. We're not going to deal with any where a is not 1. So those would be the box method. We're not going to be doing those right now. Just to really focus on what we're doing in this section instead of making it more complicated. So we're just going to be doing regular trinomials where a is 1. All right, so for the numerator, we want to know what adds to -1 that multiplies to -6. That would be -5 and a 1. So again, just a little side note over here. -5 plus 1 equals this is not even right. Don't know what I'm thinking, guys. That's why we check. Okay, try that one more time. X minus 3, x plus 2. Don't know where my head was at there. So where we got that was -3 plus 2 equals -1. And -3 times 2 equals -6. That's much better. Now in the denominator, we want to know what adds to 8 that multiplies to 16. So that would be x plus 4 and x plus 4. Because, let's see, 4 plus 4 equals 8. 4 times 4 equals 16. So once we've done this, these have no common factors. So if that happens, what that means is that this is already simplified. So our answer is actually just what we started with. This is the simplified rational function. All right, last one. So this is just going to be trinomial factoring again. Trinomial factoring again. So in the numerator here, we have x squared minus 2x minus 3. So we want to know what adds to negative 2. That multiplies to negative 3. That'll be negative 3 and 1 because a negative 3 plus 1 equals negative 2, and negative 3 times 1 equals negative 3. And then in the denominator, we want to know what adds to negative 7. That multiplies to 12. That'll be x minus 3, x minus 4. So reason negative 3 plus negative 4 equals negative 7, and negative 3 times negative 4 equals 12. Great. So once we do this, we do have a common factor here of x minus 3. So we can see here, common factor, they're exactly the same, which means we can cross them out. And then we're left with x plus 1 over x minus 4. And that's our simplified rational function. So that is it for part 1 on simplifying rational functions.